One of the big questions mathematicians try to answer is, what kinds of shapes are there? For this video, we'll focus on a class of shapes called surfaces. A surface is a shape which, locally, looks two-dimensional. For example, a piece of paper is a surface. In 3D space, the set of all points distance 1 away from the origin is also a surface. A filled-in ball we would not consider a surface, because on the inside it has volume, and so would be locally three-dimensional. Even focusing on surfaces, there are loads upon loads of possible surfaces. So to have any hope of answering our question, we need to come up with categories to sort surfaces into. Topology is the branch of maths which studies what happens when you put two shapes in the same category, whenever one can be continuously stretched and deformed into the other, without tearing or gluing any part of the shape. So, topologically, what are the different kinds of surfaces? To find out what kinds of surfaces there are, we need to have a way of making new surfaces from ones we already know. One way to make new surfaces is by gluing together parts of old surfaces. For example, if we take a square and glue together two opposite edges, we'll get a cylinder. If we start with a square and glue together both pairs of opposite edges, we'll get a donut. Mathematicians like to call donuts toruses. But we don't have to glue the edges in the same direction. If we instead glue a pair of opposite edges of a square, but flip one of them around, we'll get what's called a Mobius strip. This twisty strip only has one edge and one side. If we do this to both pairs of opposite edges, we'll get what's called the real projective plane, abbreviated to RP2. Yeah, this one's a bit weird. Another way to think of this is as follows. We'll first cut out a piece of the square, and keep track of it to glue back on later. The rest of the square is a Mobius strip, and this cut-off piece is a circle. Imagine stretching the circle almost all the way around, so it's like a cookie jar. Well, a Mobius strip only has one side, and the edge of our cookie jar also only has one side. So to complete the real projective plane, we can glue the side of the Mobius strip back onto the edge of the jar. We can also do this with more complicated shapes. For example, by pairing up the sides of an octagon, we can get a donut with two holes. It seems like there's no end to the shapes we'll get. But in fact, we've more or less seen all the surfaces already. In the 1860s, a mathematician named August Mobius, the namesake of the Mobius strip, showed that any connected surface is either an n-holed torus, or a sphere with n Mobius strips sewn into it, possibly with some holes cut out. So next time you see a strange or scary surface out in the wild, don't fret. You can be sure it's topologically the same as a surface you already know.